Hi everyone. Today we're going to study angles, particularly the angles in standard position, also degrees and radians. Let us define an angle. An angle is the union of two rays having a common endpoint. The endpoint is called the vertex of the angle, and the two rays are the sides of the angle. In the figure, the two rays are here, the ray D and ray F. The point E is the vertex, that is the common endpoint. This angle is named angle. This symbol is used to denote an angle. So this is angle DEF. Greek letters or sometimes capital letters are used to denote an angle. The symbol theta is used. Also the symbol phi. This is alpha. And the symbol beta. The symbol gamma, the capital letters A, B, C, and so on. Let us draw now the angles in standard position. Think of two horizontal rays lying on top of one another. Leave one ray fixed in place and rotate the other. I have here the figure. The fixed ray is called the initial side. The rotated ray is the terminal side. The vertex is somewhere here. And we can see the amount of rotation as shown by this arc with an arrow showing the direction of the rotation. Let us define positive or negative angles. If the terminal side is rotated in a counterclockwise direction from the initial side, the angle is said to be a positive angle. In our figure here, the initial side is fixed horizontally, then the terminal side is rotated on a counterclockwise direction. The angle formed here is positive. If the terminal side is rotated in a clockwise direction from the initial side, the angle is said to be a negative angle. Let us define measure of angles. The measure of an angle is the amount of rotation from the initial side to the terminal side. There are two measures here that we will consider. The first is degree. Second is radian. Let us start with a definition of degree. 1 degree is 1 over 360 of a circular rotation. So a complete circular rotation contains 360 degrees. An angle measured in degrees should always include the unit degrees after the number. The symbol is like a small exponent 0 after the number. We have an example here, 90 degrees. Let us define now radian. 1 radian is the measure of the central angle of a circle such that the length of the arc between the initial side and the terminal side is equal to the radius of the circle. Look at this figure. This is our radius. and this arc subtended by this angle is equal to the radius itself. So the angle here is equal to 1 radian. A full revolution that is equal to 360 degrees equals 2 pi radians. Consequently, a half revolution that is equal to 180 degrees equals pi radians. More so, the radian measure of an angle is the ratio of the length of the arc subtended by the angle to the radius of the circle. Take note, when an angle is described without a specific unit, it refers to radian measure. Example, angle of 2 units. This means this 2 is in radian measure. Hi everyone. Today we're going to study conversion of degrees to radians and vice versa. Our formula will be here, but to start with, we know that 180 degrees equals pi in radians. From this equation, we can deduce a formula that is degrees over 180 equals radians over pi. This will be our working formula in converting degrees to radians and vice versa. Let us have example 1. Convert each degree measures to radians. Letter A, 15 degrees. Letter B, 420 degrees. Let us begin with the 15 degrees. First, I'm going to write our working formula here. And then, to convert our 15 degrees into radians, we will use this formula. We will copy this again, but for this portion of degrees, we're going to write the value 15. So we have now 15 over 180 equals radians over pi. And then we will simplify from here. We will cross multiply this pi on the left side. So this will be multiplied to 15. We have now here 15 pi over 180 equals the radians will be alone on the right side. Simplifying this further, we're going to divide by 15 the numerator and denominator of the left hand side. So the 15 divided by 15 will be 1. It is not written anymore. And then we just copy the pi down here over the 180 divided by 15 is 12. And equals the right hand side, which is radians. So we have now this value pi over 12. We can simply interchange the position of the radians and the value pi over 12. To conclude, the 15 degrees equals pi over 12 in radians. This is our final answer. Let's have letter B. Convert this 420 degrees in radians. The same idea. I am going to copy this formula and then we will substitute the 420 for the degrees portion here. So it will be like this. 420 over 180 equals the right hand side, radians over pi. Simplifying further, we're going to cross multiply this pi to the left side, so the pi will be multiplied to the 420. We have now 420 times pi over 180 equals, the radians will be alone on the right side. Simplifying further, we're going to divide by 60 the numerator and the denominator of the left hand side. So 420 divided by 60 is 7. Then we will copy the pi down here over the 180 divided by 60 is 3 equals the radians. So we have now this value 7 pi over 3. That is our answer. We can just simply interchange the right hand side with the left hand side member. So we have radians equals 7 pi over 3. It means our 420 degrees equals 7 pi over 3 in radians. This is our final answer. Let us have example 2. Convert each radian measure to degrees. Letter A, pi over 6. Letter B, 2 pi over 5. Let us write again our working formula, and then let's begin with letter A, the pi over 6. We're going to write again this formula, but on this portion of the radian, we will substitute the value pi over 6. So we have now here degrees over 180 equals that value pi over 6 all over pi. In the right hand side, we have a complex fraction. We have a fraction in the numerator and the whole number pi in the denominator. Let us simplify this complex fraction. The pi being a whole number, we know that there is a denominator of 1 here. So let us simplify the complex fraction by doing this pi over 6. Then times, we're going to flip the pi into 1 over pi. And then from here we will simplify further. We can see that we can cancel the pi and the pi in the numerator and denominator respectively. When we do that, the right hand side is simplified into 1 over 6. From here, we're now to cross multiply this 180 to the right hand side. So the 180 times 1. And the degrees will be alone on the left hand side. We have now 180 times 1 all over 6. Since this is a factor of 1, we can simply remove this 1. We can now simplify this into 180 over 6. And when we get the quotient, the answer will be 30. Of course, we will not forget the symbol for degrees. We will put that small o exponent to denote degrees. So our answer here is 30 degrees. To conclude, the radian pi over 6 equals 30 degrees. This is our final answer. Let's have the letter B, the 2 pi over 5. Again, we will copy this formula, and on this portion of the radian, we're going to substitute that value 2 pi over 5. So we have now degrees over 180 equals the 2 pi over 5 all over pi. Then we will simplify. We have here a complex fraction. So we will have to write it again into the 2 pi over 5 times. We will flip this pi into 1 over pi. And the right hand side, we can now cancel the pi and the pi respectively. When we do that, the right hand side becomes 2 over 5. To simplify further, this 180 now, we will cross multiply to the right hand side. It means it will be multiplied to the number 2. So 180 times 2 all over 5. And the degrees will be alone on the left hand side. Simplifying further, the 180 times 2 is 360. Again, the denominator 5 is there. And 360 divided by 5 equals 72. We will now affix the degree symbol. So our answer is 72 degrees. To conclude, the radian 2 pi over 5 is equal to 72 degrees. This is our final answer. Hi everyone. Today we're going to study length of an arc and area of a sector. Let us start with length of an arc on a circle. The length of an arc on a circle is illustrated by this figure, and let us have a formal definition. In a circle of radius r, the length of an arc S, subtended by an angle theta in radians, is given by the formula S. This is the S, that is the arc. S equals the radius times the angle in radians. Please note, the arc corresponding to one full revolution of a circle is the circumference. Let us have example 1. Find the length of an arc of a circle of radius 12 inches, subtended by a central angle of pi over 4 radians. Let us first collect the given. The radius is 12 inches. And the angle in radians is pi over 4. The formula is S equals R times theta. Then we will substitute now the values. The R becomes 12 and the theta is the value pi over 4. Then we will simplify further. We can cancel this 12 and 4, it becomes 3, and then we will copy the pi. So the S, the length of the arc, equals 3 pi, and we will not forget the unit of measurement, that is inches. So our final answer is 3 pi inches. Let's have example 2. Find the arc length along a circle of radius 10 units, subtended by an angle of 120 degrees. Let us collect the given first. The radius is 10 units. The angle is given in degrees, that is 120 degrees. The formula is S equals R times theta. But we must convert this angle as expressed in degrees into radians. The conversion formula is here from degrees to radians. We will write again the formula, and for the degrees, we're going to put the 120 value here. And then we will simplify further. We can reduce this 120 over 180 into lowest term. We will divide by 60. So the 120 divided by 60 is 2 over the 180 divided by 60 is 3. And this is equal to the right hand side radians over pi. And then this pi we will cross multiply on the left side. So we will now have 2 pi over 3 equals radians. So this is now the value of this 120 degrees, which is equal to 2 pi over 3. Now we can proceed with our computation of the arc length. We will now substitute the values on the formula. So S equals, the radius is 10, times the angle that must be in radian. We will now use the 2 pi over 3. From here, we will simplify further. 10 times 2 pi will get 20 pi over the denominator 3. We will just copy. So the arc length equals 20 pi over 3. We will simply attach our unit of measurement. In here, it simply says units, so we will copy that. This is our final answer. Let's go now to area of a sector. First, let us define a sector. The sector of a circle is the area bounded by 2 radii, that is the plural of radius, and an arc. Here is a picture of a sector. Let us go now to area of a sector. The area of a sector of a circle with radius r subtended by an angle theta in radians is given by the formula A equals 1/2 theta r square. Please note the sector corresponding to the full revolution of a circle is the area of the circle. Let us have examples. Example 1. Find the area of a sector of Shinas roundabout, approximately of radius 10 meters, subtended by 2 radians. Given is the radius, that is the 10 meters, and the angle in radians is 2. Using our formula A equals 1/2 theta r square, we will now substitute the values. So A equals 1/2, theta is now 2, times the r square, the radius is 10, and we copy the square. We will simplify further. We can cancel this 1/2 and the 2, and then we will expand the 10 square. So the area is 100. For the units, we're going to write square meters because we are dealing with area. This is our final answer. Example 2. An automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees, as shown in the figure. What is the area of the sector of grass the sprinkler waters? Let us collect the given. The radius is 20 feet and the angle is given in degrees, that is 30 degrees. Then we will write our formula for the area of a sector. But first, let us convert the angle in radians. The conversion formula is here. Let us now substitute the value. 30 over 180 equals radians over pi. Let us simplify our left-hand side. The 30 over 180, if we divide both by 30, it will be reduced to 1 over 6 equals the right-hand side is radians over pi. Now this pi we will cross multiply to the left-hand side. So 1 times pi will be pi over 6. This is the value of this 30 degrees in radians. We can now substitute the values in our area formula. So A equals 1/2, the theta. We will now use the value in radians, the pi over 6, times r square. Our radius is 20. So we put it here. We will simplify further. We can combine the 1/2 and the pi over 6. We multiply 2 by 6, it becomes 12. So here we have pi over 12, and the 20 square is 400. We will simplify further. We can cancel the 400 and the 12. We can divide each by 4. So the 400 becomes 100. Then we copy the pi all over. The 12 divided by 4 is 3. So our answer here, the area is 100 pi over 3. For the units of measurement, we will write square feet or feet square to denote an area. This is our final answer. I hope we learned something from this video. See you again next time.